Hello everyone. This is in continuation to our topic analytical geometry. This is question 14. Find the area of the quadrilateral whose vertices are 2, 1, 6, 0, 5, -2 and -3, -1. Let us draw one quadrilateral first. Now let us consider this as A, this as B, this as C, and this as D. The first vertex, we will call it as A. So this is 2, 1. Second vertex is B, 6, 0. Third vertex is C, which is 5, -2. The last vertex is -3, -1. Now we can notice area of quadrilateral ABCD is equal to, I can bring in a division. I can draw a line from A to C so that this can become two triangles. So I can say this is area of quadrilateral is nothing but area of triangle ABC plus area of triangle ACD. Let us call this as x1, y1, this as x2, y2, this as x3, y3, and this as x4, y4. Now let us first find out area of triangle ABC. Area of triangle ABC is 1/2 times modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2 under modulus. So this is now substituting the values. X1 is 2 and then y2 is 0, y3 is y3 is -2. So minus or -2, it becomes +2 plus x2. x2 is 6 times y3. y3 is -2 minus y1 minus 1 plus x3. x3 is 5. Then y1 is 1. y2 is 0. Let us evaluate this. It is half times modulus of 2 into 2, 4. Minus 3 into 6 is -18. And this is 5. So now 4 plus 5, it is 9. 9 minus 18 becomes -9 under modulus by 2, which is nothing but 9/2. Or we can say 4.5 square units. Now, let us find out the area of triangle. The second triangle is ACD. So here we don't have x2, y2. Accordingly, we'll write the formula x1. Then we will write y3 minus y4 plus x3 y4 minus y1 plus x4 y1 minus y3 under modulus. So that becomes half times x1. x1 is 2 times y3. y3 is 2 minus y4. y4 is -1. So it becomes +1 here plus x3. x3 is 5. So plus 5 times y4. y4 is -1 minus y1 minus 1. And then plus x4. So plus, that is -3. y1 1 minus y3. y3 is -2, so this becomes +2 then. So this will become 3 into 2, 6, minus 2 into 5, minus 10. This is 3 into 3, minus 9. Let us recheck this. X1 is 2, y3 is -2, y3 is -2. So sorry. So here it becomes -2. And then y4 is -1, so it becomes +1. Plus x3 is 5, okay, times y4 is -1 minus y1 minus 1 plus x4. x4 is -3 times y1 is 1 minus y3. Minus or minus, it becomes +2. Okay, so this is now -2 plus 1 is -1 minus 2. And here it is -2 into 5 minus 10. This is -9. So you get modulus of -21 by 2, which is nothing but 21 by 2 or 10.5 square units. Therefore, area of quadrilateral ABCD is equal to 4.5 plus 10.5 square units, which is 15 square units. So that is the solution for this particular question. Question 15, show that the points A, B, C plus A, B, C, A plus B, and C, A, B plus C are collinear. So first of all, we will consider these values as x1, y1, x2, y2, x3, y3. Now let us proceed. If the points are collinear, then the area of triangle ABC will be 0. Means it cannot form a triangle if it is in a straight line. Collinear in the sense straight line. So let us check the area. It is half times modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Now x1 is b, and then y2 is a plus b minus y3 minus b minus c plus x2. x2 is c, y3 is b plus c minus y1 minus c minus a plus x3. x3 is a y1 is C plus A minus y2. It becomes minus A minus B under modulus. Now let us evaluate this. This B and B gets cancelled, minus plus C minus C plus A minus A. Now let us multiply. It becomes BA minus BC plus BC minus AC plus AC minus AB. Minus AC plus AC gets cancelled, minus BC plus EC. BA minus AB both are same. You get half times modulus of 0, which is nothing but 0 by 2, which is 0. Therefore, we can say points A, B, and C are collinear. So that is the solution for this question.